Bismillahirrahmanirrahim. Hello, welcome you all to this AACE Greater Cairo International Technical Meeting, and it's on artificial neural networks and their application in construction claims. It's presented by Dr. Rania Fayed, and I have to say that when I had previously in the early 2000s, probably in 2001, I had come across this issue of neural networks. It was a very demanding topic in a lot of international journals. So we're very happy to have Dr. Rania present this, this presentation today. So Dr. Rania, the floor is yours.
Thank you, Dr. Walid. Our topic is about application of artificial neural network in construction claims. First, I'd like to introduce myself. My name is Rania Fayed. I got my PhD in construction management from the American University in Cairo in 2017, and my master's degree in civil engineering from Mansoura University in 2006, my PhD in civil engineering from Mansoura University in 2002. I'm PMP certified since 2009. I am a member in Chartered Institute of Arbitrators and a regular member in AACE. I'm a contract manager at HEL International, assistant professor at Faculty of Engineering at Sheikh University, and a teaching assistant at the American University in Cairo. The main outlines of this presentation are introduction to artificial neural network, the main components of the network activation rule, learning rule, the mechanism of supervised learning, an overview of application of artificial neural network in construction management, and finally, application of artificial neural network in construction claims. First, I'd like to give introduction to artificial neural network. It's one member of the family of artificial intelligence. Artificial intelligence family includes a lot of techniques that mimic the human perception and reasoning in solving complex problems, such as fuzzy logic, neural network, and genetic algorithm. Neural network, also called connection nested model or parallel distributing processing. It consists of a pool of sample processing units called neurons, nodes, or cells, which communicate over a large number of weighted connections and send signals to each other. So it's a massively parallel distributed processor that has a natural ability to store experiential knowledge and making it available for use when needed. Simply, artificial neural network is a machine that is designed to model the way in which the brain performs a particular task or function of interest. So it resembles the brain in two respects. First, knowledge is acquired by the network through a learning process. And second, interneuron connection strengths, known as synaptic weights, are used to store the knowledge. So artificial neural network performs what's called pattern recognition after undergoing a training or learning session, through which the network is represented by a set of input patterns along with the category in which each pattern belongs to. And then it is presented by a new pattern which hasn't been seen before, but it belongs to the same population of patterns which are used during the training or learning process. At that time, the network is able to identify the pattern in which this the class in which this pattern belongs to, depending on the information extracted during training or learning process. This function is called recall. The third function is generalization. Generalization is the ability of the network to produce the output or reasonable output for inputs not encountered during training or learning process. So the network is able to learn, recall, and generalize. The processing element in the neural network is neuron. The human brain consists of 10 billions of neurons. Each biological neuron is connected to several thousands of other neurons, the same as the connectivity in artificial neural network. This figure shows the structure of biological or natural neurons. Natural neurons receive signals through synapses located on the dendrites or membrane of the neuron. When the signals received are strong enough, the neuron is activated. Then the neuron cell body, which is called soma, processes the incoming activation and converts them into output activations or signals. These signals are transmitted through axons into another synapses or to activate other neurons. The complexity of real neuron is addressed when modeling artificial neuron. This figure shows the schematic of artificial neuron. It consists of inputs, the same like synapses, which are multiplied by weights that represent the strength of the signals, and then computed by a mathematical function which determines the activation of the neuron. The higher the weights, the stronger the inputs that are multiplied by it. Also, there are negative weights, but we can say that signals are inhibited by negative weights. Depending on the weight, the total computation of the neuron may differ. So by adjusting the weights, we can obtain the output we want from a particular input. But in artificial neural network, where there is hundreds or thousands of neurons, it's difficult to do that by hand. So we should find an algorithm to adjust the network in order to obtain the desired output from particular input or from the total network. This algorithm of adjusting the weights is called learning or training process. After activation of the neuron, another function computes the output of the artificial neuron. And then the neural network combines artificial neurons in order to process information. The network consists of three main components: the network, activation rule, and learning rule. First, the network. It consists of a set of nodes or units connected together via directed links. So it consists of an input layer and output layer, and between them a set of hidden layers. Hidden layers can be one layer or more. The source node in the input layer supplies inputs to the first hidden layer, and then the outputs of the first hidden layer are applied as inputs to the second hidden layer, and so on. If each node in each layer is connected to each other node in the adjacent layers, so the network is called fully connected. But if some links are missed, so it's called partially connected. There are two kinds of neural network or the network: the feed-forward network and recurrent network. In the feed-forward network, the information flows from input to output in one path, but the recurrent network includes at least one feedback loop. The number of neurons in the input or layer is determined according to the categories of the input parameters that are supplied to the network, while the number of neurons in the output layer are determined according to the number of the desired outputs required from the network. Each node in the network has a numeric activation level associated to it at specific time, so that the overall pattern vector of activation represents the current state of the network at specific time. The second component is activation rule. Activation rule is a local procedure that each node follows in updating its activation level in the context of input from the network node. It includes a summation function and activation or transfer function. First, the parameters are assigned to the inputs of the neurons. And then the output of the neuron is a nonlinear combination of the inputs weighted by weight parameters with an additional constant term called bias. So the weights are adapted coefficients that determine the strength of the input signals as registered by the neurons. These strengths can be modified in response to various training sets or according to the network architecture or its learning rules. The summation function is more complex than just weight sum of products. So it may take various ways before it passes to the transfer function, and it depends on the architecture of the network. So that some summation functions are applied to an additional activation function in order to allow for the summation function to vary with respect to time. Then the result of the summation function is transformed into a working output through an algorithm called activation or transfer function. There are two types of activation function: step-type function and sigmoid nonlinear function. In the step-type function, the summation can be compared with some threshold that determine the neural output. So if the summation is greater than the threshold value, the processing element generates signal. But if it is less than the threshold value, no signals are generated. So that the step type in the transfer function may output 0, 1, or negative 1 and 1, or any numeric combination. The best type of activation function is a sigmoid or S-shaped function, as it has the ability to analyze non-linear similarities in the nonlinearity among variables, such as tangent or sine or cosine function. The third component in the network is the learning rule. Learning or training is a process by which the three parameters of the network are adapted to a continuing process of stimulation by the environment in which the network is embedded. There are different types of learning, but the type of learning is determined by the manner in which the parameter change takes place, so that it's a procedure that describes how the weights on connection should be altered as a function of time in order to better approximate the desired function, or to minimize the difference or the error between the actual output of the network and the desired output. There are two main types of learning: supervised learning and non-supervised learning. The supervised learning is learning by examples or real cases, in which the weights in the network are adjusted under the supervision of a teacher, so that the network is supplied by inputs and desired outputs. Then the response of the network to the inputs is measured. The error is the difference between the actual output of the network and the desired output. Then this error is used where the weights are modified to reduce such a difference between the two errors, where the new weight is a summation of the old weight and the error or the difference between the two outputs multiplied by the input. The second type of learning is the unsupervised learning, or is called the clustering and classification. In this type of learning, no teacher is applied, so that the training process in the network has the ability to discover the similarities between the elements of the database and translate it into vicinities between the new data representation. Only inputs are supplied in this type. No desired outputs are supplied. The network adjusts its own weight so that similar inputs cause similar outputs. The network identifies the patterns and differences in the inputs without any external assessment. The most popular type of learning is the supervised learning. The following points discuss the process of supervised learning. Using the neural network depends on having a huge number of databases, so that the database or the case studies are classified into training and testing sets. The training set represents nearly 70 to 80% of the case studies, and the rest for the testing. So if you have 20 cases, we set 15 for training and 5 for testing. Then we create the network, determine the number of neurons in the input layer, the number of neurons in the output layer, the number of hidden layers, and number of neurons in each hidden layer. The number of neurons in each hidden layer is determined by trial and error, or by identifying the relationship between the number of neurons and the produced error. Then we determine the activation or transfer function. It's not a condition that the activation function is the same for each hidden layer. It may differ. Then we initiate the weights by any value. Then we subject the network to the training cases one after the other. We consider the first training case and process the inputs using the initial weights and predict the outputs of the network. Using the initial weights, the actual output of the network for this training case will not match the desired output. This is the error. So we use this error to adjust the weights using the previous equation, and then using this weight to subject it to the next training case. Then we calculate the output, compare it with the desired output, and then calculate the error and adjust the weight and use it for the next training case, and so on. We keep doing this process till finishing all the training cases, and then accumulate the error for all the training sets. Training process stops working when the total error for all the training sets is tolerable. But if it is not tolerable, so we repeat the training process again for the training set until using the weights obtained from previous training until the total error is tolerable. Once the training process is finished, we start testing using the testing set of cases with the same steps until the total error for the testing set is tolerable. Application of artificial intelligence and specifically artificial neural network in construction management has increased dramatically in the last few years in order to get benefit of merging such different disciplines. So a lot of papers have been published in this regard. Some papers use neural network for modeling labor productivity using historical data and the impact of change orders on labor productivity. Others use to model the classifying construction contractors and managing owner risk of contract default. A lot of papers discuss different cost topics such as modeling highway construction costs and modeling contractors markup estimation, predicting cost deviation and reconstruction projects, and building decision support system for bidding in construction. The main purpose of this study is to make benefit of application of artificial neural network in construction claims. Claims are classified into time claims and cost claims. Time claims in which time for completion is extended due to delays by employer or contractor or any natural event. And cost claims in which one party is bears or incurs additional costs or losses due to other parts' fault or any other reason, but it's subject to compensation. And this additional cost is added to the accepted contract amount. So the aim of application of applying artificial neural network is to predict the percentage increase in time or in cost in construction projects in order to take preventive action or avoid the impact of such delays or such additional cost in the project. So that artificial neural network, so that these claims may happen due to a lot of reasons or a lot of causes, such as type of project location, the type of contract conditions, type of client entity, method of payment, or due to variations or changes that happen during construction or due to design errors. These all are the input data or the impacts that may cause the claim. So in order to get benefit of such application, we need a simple model in order to predict the percentage of increase in cost and time. After training the model or the network using database collected from previous surveys and using the input parameters according to the database collected. The model was built in Excel and run using AACE software. This software is used to solve decision-making problems. It deals with the different techniques of artificial intelligence. Also, there are a lot of softwares that deal with neural networks, such as MATLAB, neural net, NeuroTools. The model output is to predict the percentage of increase in cost and in time in the projects, based on the input data from the data collected, which are type of project, client, public or private entity, contractor organization, type of contract, method of payment, original value or accepted contract amount, and original duration. Each type of these inputs is classified into different categories according to the data collected, so that the type of project is classified into industrial, touristic, heavy project, infrastructure, heavy projects such as roads, bridges, or airports, infrastructure, power plant, water or wastewater treatment plant, administrative buildings, commercial and residential buildings. The type of client entity was classified into private and public entity. Contractor organization was classified into prime or main contractor, consortium, and subcontractor. Method of payment was classified into unit rate and lump sum. It should include cost plus, but the data collected, the cases doesn't include the cost plus contract. Type of contract, Law 89, ad hoc, and FedEx contract. It's better you can classify FedEx to the different editions, but this wasn't available in the data collected. Cost per month, in order to facilitate the input data to the network, We calculate the cost per month as the product of the division of the original value and original duration. These parameters are identified according to the data collected, but it may differ in other models. Neural network deals only with numeric values. So we assign to each category under each type a numeric value in order to be identified by the network. The data collected was to 54 case studies. 39 cases were assigned for training and 15 cases for testing. This is an example of one case study. The type of project was industrial. The client was a public entity. The contractor organization was consortium. Type of contract was ad hoc. Method of payment was lump sum. Original value or accepted contract amount was 166 million, and the original duration was 37 months. The percentage of increase in cost in this case due to claims was 10%, and in time was 40.2%. As a neural network is an optimization problem, so it has three parameters: objective function, variables, and constraints. The objective function is to minimize the total error for training set, or to minimize the difference between the actual output of the network and the desired output for both cost and time. The variables are the weights between the input layer and hidden layer, and between the hidden layer and output layer. No constraints were set in this problem. The first step in the network is the scaling, or to prepare the input data to the model. Preparing the input data by determining the number of input neurons, the data for each, preparing numeric values for each input neuron, and preparing the data for the output neurons. In our model, we have three layers: input layer, one hidden layer, and an output layer. The input layer consists of 6 neurons. Each neuron refers to the type of the input parameters. So the first input neuron refers to the type of project, and the second input neuron refers to the client type. The third neuron refers to the contractor organization. The fourth input neuron refers to the type of contract conditions. The fifth neuron refers to method of payment, and the last one refers to the cost per month. In the output layer, we have 2 output neurons, each one neuron to predict the percentage of increase in cost, and the second neuron to predict the percentage of increase in time. And we have one hidden layer consists of 4 neurons. Each neuron in the input layer is connected to each other neuron in the hidden layer, and each neuron in the hidden layer is connected to each neuron in the output layer. The input data are supplied from the input neuron to each hidden neuron by strengthening the signals and then activating it. Strengthening the signals are by assigning the weights. This table shows the weights between each input neuron and each hidden neuron. The tables are assumed to be any values at the start, and then they are adjusted during iterations using the software. Then the inputs to the hidden neuron is the sum product of the summation function, which is the sum product of the input data multiplied by its weight, each one multiplied by its weight between each input neuron and each hidden neuron. So this table shows the results of the summation function for some of the training set. For example, the first case study, the value of the first hidden neuron is the sum product of the input of each input neuron multiplied by the weight of this input neuron and the first hidden neuron. The same for the second and third and fourth hidden neuron. The output of the summation function is the input to the hidden neurons. The output of the hidden neuron is after the activation of the signals using the activation function. Activation function is used to be a sigmoid function sign the product of the summation function. This table shows the results of the activation function for some of the training set. Activation function output is the output of the hidden neurons, which will be transmitted to the output neurons in order to produce the final output of the network. Transmitting the signals by first strengthening the signals using the weights, This table shows the weights between each hidden neuron and each output neuron. Then applying the summation function, which is the sum product of the inputs, which are the output of the activation function, and the weights between the hidden neuron and the output neuron. This table shows the results for some of the summation function. Then the final step is to activate the signals before it passes to the output neurons by using the activation function, the same as in the hidden layer, find the product of the summation function. This table shows the final output of the neurons, of the output neurons and the network for each of cost and time. This table shows the desired output for cost and time. And this table shows the error. It is the absolute difference between the actual output of the network and the desired output for both cost and time. And this is the total error, which is the summation of the cost and time error. For example, in the first case study, the network predicts the percentage of increase in cost to be 9.8% and in time to be 25%. The desired output for cost was 20% and for time was 25%. The error in cost between the actual and desired output is 10.14%, but in time it's nearly neglected. So the total error is 10.14%. The training process stops working when the total error for all training set reaches 15.09. Then we starting the testing set, the testing process using the testing set of cases, produce the actual output for cost and time, and compare it with the desired output, calculate the error, which is the difference between the actual and desired output, and the total error for both cost and time. The training process stopped working when the total error for testing set reaches 2.36. This chart shows the comparison between the actual output of the network and the desired output for the percentage of increasing costs. So we can see that the average percentage of error for all the training set was 26%. Some cases studies the difference between the actual and desired output was nearly neglected, as in case study number 3 and 6, 9, and 15. Some case studies records less than 10% of error, such as case study number 10, 11, and 13. But we have 2 case studies that records higher error, which are case study number 4 and number 14, but it's acceptable. This chart shows the comparison between the actual and desired output for increase in time. The average percentage of error for the increase in time was 20.5%. The error was nearly neglected in case studies number 3, 7, and 9, and less than 2% in 2 and 10 and 12 also. The case studies that records high error was 2 case studies for 5 and 8. I would like to highlight that these results based on using one hidden layer and consists of 4 neurons. But increasing the number of hidden layers and increasing the number of neurons in the hidden layer affect the results and definitely decrease the error. Some models depend on reaching 50 and 80 number of neurons in one hidden layer. I won't say that this is the main idea of a paper. We are working in it now, but we are trying to enhance the idea and to be more practical by adding to the input parameters the actual causes that lead to such increase in time and cost, and also to try to make to be more specified to build a model for each type of contract condition. These are my references, and the top of these references are the lectures of Dr. Osama Hosni in Advanced System Analysis for Construction Engineering. Thank you for your time, and I'd like to know your feedback. And if you have any recommendation that can be considered in the paper. Thank you.
Thank you very much, Dr. Rania. It's a very interesting presentation. We have a few questions for you. So I'll start to refer to these questions. They're in the chat box. So the first question is, do you think that artificial neural networks, are they used frequently in the MENA region, or are they used in a particular region?
No, I think it can be used in MENA region. It can be used in a lot of regions.
No, I mean, مش can be. I mean, are they used in fact in, for example, mostly in the States, for example? Wala, did you encounter any case where they have been used in the MENA region, for example, in this past?
No.
From your experience?
No, I saw a lot of papers that use it in MENA region, but you mean practically it's
Yes.
used?
Yes.
I'm not sure, but yeah, but I think it's used. Yeah, I'm not sure really, but what I read this a lot of papers in this topic using it.
Okay, a lot of papers from practitioners in the MENA region, yeah.
Yeah, yeah.
Okay. Second question. Yeah, were there any studies that you, because you mentioned in the presentation that neural networks, they sort of predict, for example, potential increases in time and cost by inserting the inputs and you know, you have the outputs and you're calibrating the errors and you're trying to make, as you mentioned, the more hidden layers, the more neurons, the better the results, the more accurate the results. Is there any study that compared the output of the ANNs to the actual, for example, actual cost and time increases in a project?
Do you mean the relationship between the number of neurons and the actual output, or
no? I mean, say there's a case study, and the case study predicted using using a lot of a good number of neurons and everything, that the project time will increase by something. So now this project has been completed actually, and is there any comparison between the actual time that the project ended and the predicted time of the neural networks? Is there any?
Do you mean that after the project finished and then we compare the actual?
Yes.
Really, no. All the papers are based on the case studies already happened, and then we use the network to use these case studies to train the network, and the actual output of the network is compared with what really happened. Okay, so we see the percentage of error. Okay, as we made here, in this model, we have the actual output with the actual increase in cost and in time, and the network was applied to predict, so we can find the error. Is it how much the accuracy of the network?
Okay, so this maybe leads me to another question. When you say actual output, because in the presentation you mentioned this desired output, right? So when you say desired, is this the actual? And is the desired output the same as the actual in the project?
Yeah, the desired output is the desired from the network, but it's the actual that happened in the project.
Okay.
Actual output is the actual output from the network, okay? And the desired output, what happened really.
Okay. I believe, Hussam, you have a question for Dr. Rania?
I'm sorry. Dr. Rania, thank you very much for the presentation. It was very informative and interesting, actually. I believe there are a lot of other details related to this subject, but cannot be covered in 1 hour. My question is, the nice iteration technique you implemented, does it have a kind of interface or integration with the commonly used software program? You know, when we study a claim, for example, to analyze the extension of time or how much time the contractor is entitled to, we use normally the common softwares here in Egypt, Primavera, Microsoft Project, SureTrack, whatever. So my question is, does this technique have any interface with the outputs, or even can be can generate some input to such software that are compatible with such softwares?
You mean already the model is built using software that deals with neural network, such as we use the
I understood this and I فهمت that. And my question is, can we use that? Can you use this to interface with حاجة تانية لو أنا يعني اخد مثلا input منه؟ can I take input من السوفت وير دوت او whatever السوفت وير دوت، او اخد output من برنامج تاني ادخلها فيه يعني؟
I think it can be done according to the language of the software. I mean, say I made this before when I was using software for simulation. It was AnyLogic, okay? But AnyLogic, and I want to make optimization to the model using other software, okay? So I get the output of the software, the Java language.
I understand.
Okay, so I get the output get the Java language, the output of the model as Java, and then entered it into another software, okay, in order to use it for programming, to use the other software. So it can be done if the language of the two softwares are
compatible.
Are compatible, yeah. Yeah, it can be done.
Okay. شكرا.
Dr. Rania, the last question is now are neural networks used in based on your knowledge and experience, have they been used in real time during the project to affect decisions for the project? For example, let's say we're in a project that is the duration of it is 12 months. And after the first month, the employer decides to issue a change, okay? So then but before trying to issue the change, say if there's a neural networks applied in the project, so then the project manager would probably use the model to predict the time, for example, the time overrun or the cost increase in the project. And say, for example, if they use this model and then they found that that there's a substantial, for example, impact, then they would not use neural networks. Was it? I mean, you know what I mean? Like, I mean, was it applied during the duration of the project to affect decisions? Well, it's only applied at the end to. And when is it applied in real time? Say, if you're in in a project, how do you apply neural networks to make the most benefit of it while you're in the project?
The best time is before the project, okay, to predict. But if I can use it during the project, I think there is no problem if I use it during the project. The neural network depends on the experience. Okay, I'm training the network or the model with the previous experience. So what has happened if it is producing the output depending on the previous experience? Okay, it will recall case studies like the one that I will enter to the network and produce the output. So I think it can be used at any time depending on the similarities or the experience it acknowledges.
طيب then let me برضو معلش we're putting a lot of pressure on you, but you're doing very well so far. Like now that you mentioned this, in common law jurisdictions like in the UK, in the US, they go by case precedent. So they have cases. So for example, if I input into the neural networks these case decisions, for example, and now I want to issue this variation in the project that actually يعني طبعا the network has a database of the previous decisions. And so if I want to make a variation and I want to know, يعني أنا as an employer, I want to know if this variation is going to result in additional time or not, and then say based on the neural network's output, then I might make a decision. Okay, no, I'll reconsider. I'm not going to issue this change. Did you read any research in this regard, or did you have any experience with this in this issue? Like, did it really affect?
Do you mean, doctor, that I want to make a change order that will have a time or cost impact, and then I didn't make the change?
Yeah, no, I mean you want to make this change. You want to make this change. At this change, طبعا there is case law that is similar, and a few cases that are recorded in neural networks that deal with the same kind of problem that you're trying to initiate. So did you read any research that where مثلا case law was inserted, and then based on the neural network's output, the user of the neural network said, okay, no, I will not, I will not go forward with this change, or I will modify the change, and as it affects the decision of the user of the network on the project. Did you come across حاجة زي كده, or?
I came across papers that discussed the frequency of this of occurring of such variation or such a claim or such cause of claim. In some papers, build the network on the frequency. I want to know such claim or such a cause of claim, okay, the frequency of happening it in this project, in this specific project, depending on the previous experience in the network. This already happened. This already occurred, this paper. So by the frequency, I will know if it will zero happen in such case or such type of project. Maybe it will not happen at all. As you said, if I got your point, you need to know that it will happen or it's better not to happen. This variation. So the decision, yes, some papers was built on the frequency of happening of this claim or this risk causing a claim.
So if in those papers, if the frequency is, say, for example, it's very high, I mean so what is the action that they would take? I mean, those users of the network, what would they do if their frequency is going to be high? Do they change, for example, the design? Do they say that no, we will not issue this change and we will do something else instead? Well, what would they do?
If I know that the frequency is high and I know the impact, okay, that it will cause time impact and cost impact. Say it will cause a lot of delays, or cause such delay or additional cost, too much additional cost. So I should take preventive action, okay. But I didn't read a paper that said what are the preventive actions, but it depends on the type of the project, or it's case by case, okay. But if I have design errors and it will happen and will incur, the employer or the contractor will incur a lot delays or additional costs. So I think you should take preventive action at the beginning, okay, before starting.
Then I would suggest, Dr. Rania, that maybe this is something that you probably can address in your paper, in your research, just for, so it's of practical use to users of neural networks in real time in products. So for example, the neural network makes a prediction and about the frequency. So then what are the preventive measures that you mentioned that users can do using, so that, because that gives a good an idea of what to do with the output that the neural networks gives us, you know.
It's a good idea to also to give the solution, to give the solution for such a problem. Yes, I think it's a good idea, and I think we can make also a model for such decisions taken, to better know what are the better decisions, to predict the better decisions to be taken in such case, depending on the previous cases.
Right. Any other questions from the participants?
No, thank you very much دكتورة رانيا. Thank you very much دكتور وليد. ربنا يجزيكم كل خير على المحاضرة اللطيفة دي.
الله يخليك. الله يخليك باشمهندس حسام.
ثانكس دكتور رانيا. كان البرزنتيشن يعني فيري مهم جدا، وعمل لنا انتروداكشن جميله للارتفيشال نيورال نتوركس، فشكرا على مجهود حضرتك يعني.
العفو على ميرسي.
ألف شكر دكتور رانيا. Thank you very much for your time and for this informative presentation. Thank you very much. Thank you all.
شكرا. Have a good day. Bye bye.
شكرا. You too. مع السلامة.
مع السلامه.